Welcome to Mathlink, where we connect the dots. I am Mr. C, and in this particular unit, we're going to look at solving complex fractions, a little more complex. So hopefully you had an opportunity to look at solving simple equations. Now we want to solve more complex equations in this unit. So let's get started. Solving equations. Again, hopefully you familiar yourself with solving simple equations from some of the videos and resources that we have on our Mathlink website. Looking at that will actually help you in solving complex equations. So let's go through some of the procedures in solving complex equations. The procedure for solving equations consists of combined operations where you have adding, subtracting, multiplying, parentheses, everything in between. First thing you want to do is remove those parentheses. And then you want to combine like terms on each side of the equation. Make it simpler. Combine those terms, make it simpler for you to solve. The other things you want to do is get all unknown terms on one side and all known terms on the other side of the equation. That's very helpful, and I'll show you how to do that. Combine like terms again, multiply when you need to, and divide, apply powers, root principles of quantities. Now, I'm going to show you an example and show the order how we do it. It's almost like reverse, how would say it, order of operations. If you know the order of operations, where you start off with parentheses, exponents, with our multiplication, division, adding, and subtracting, to solve, you kind of reverse it. You go from adding, subtracting, remember this, multiplication, then you do your exponents, and then you do your parentheses. So it's kind of reverse. So let's look at this problem here. It says solve for x. Again, you want to review the simple equation, solving simple equation video, and this will help you when you want to talk about these type of problems too. You want to get x by itself. We got 8x plus 12 is equal to 52. Now we know the x is not by itself, so we need to know what are we going to do? Get rid of the 8 or get rid of the 12 first? In this case, we want to get rid of the plus 12 first. We want to start that direction. And so how do you get rid of plus 12? You subtract on both sides, 12. So I'm going to put minus 12 on both sides. What happens is this will cancel, be 0. And so what you're left with is 8x is equal to, just bring down the equal sign, 52 minus 12. In this case, I believe it's 40. Now, the x is still not by itself. To get x by itself is 8 times x. We have to divide it by 8. This cancel because the opposite of multiplication is division. And so we end up with x is equal to 40 divided by 8, or just say 5. And that's how we do this particular problem. Now, your answer is not always going to be integer values or whole numbers. So let's look at another type of problem. And we'll look on this particular slide. And let me give you another one. I'm going to cross this out so you won't be confused looking at this here. Let's look at saying we have 3x minus 7, okay? And you can pick a number where you want it to be equal to, okay? Okay, let's say 8. So we want to get x by itself, and that will give us the answer once we get x by itself. So the first thing we need to do, and I think you understand the first thing we need to do is get rid of that 7. So we got a 3 and a minus 7. So we have to get rid of the 7 first. So how do you get rid of that? You just add both sides by 7. This cancels. So we end up with 3x is equal to, I believe if my math is right, 15. Now we have 3 times x is equal to 15. To get rid of that 3, we have to divide by 3 on both sides, because what you do on one side, you do on the other side. And so we end up with x is equal to 15 divided by 3, and I believe that is also 5. And so that's our final answer. And then you could check and see if that works. So 3 times 5 is 15 minus 7 is 8. So that is my answer. So let's look at another type of problem, and we're going to solve for y. So this equation consists of combining operations. We have multiplication if you see it, and we have some other subtraction and other operations here. So the first thing I would do is get rid of the parentheses. And we learned that in some of our videos in the past. And if you haven't looked at that, look at some of the videos in this algebra section to know how to get rid of the parentheses. But what we learned here is that we have 14y. So let me write this. We have 14y, and this minus 6 is times the y and also the -3. Now remember, it's minus 6, so watch what I'm going to write. It's going to be minus 6y, and then don't forget that minus is going to be with also, or subtraction sign with the other subtraction sign, which will make it a positive 6 times 3, which is 18, which is equal to 22. And that's how I got rid of the parentheses. Change the signs and distribute, called the distribute property. Now, some of the procedures we talked about in the past, it says combine like terms. So let's combine some of our like terms. Here's one here, here's there, make it a lot easier. If we do this correctly, we end up with a 14 minus 6, which is 8y plus 18 is equal to 22. Now let's do what we did before. We're going to get y by itself. But what we're going to do first is we're going to subtract 18 on both sides. What we do on one side, we do on the other side. We do that first. This gives me 8y is equal to, and do 22 minus 18. In this case, we have the 4. And then we divide both sides by 8, because the opposite of multiplication is division. And therefore, we end up with y is equal to 4 over 8. Now, let's reduce that. 4 over 8 is the same thing, if I'm not mistaken, as 1/2. And so that's what we end up with, and that's what we have. And so you always want to check and see if your answer is right. So that'd be 7 and 3. 3, that will give us that. Yep, and that's what we have. And so that answer is correct. So let's look at a few more problems. So we're in our whiteboard and see how we can solve a little more complex problems. So for this one, again, we want to get x by itself. Now, the first thing I want to do is get rid of those parentheses first. That's what I would think. The x plus 4, so that's 3 times x plus 4. Now, how do we get rid of that parentheses? We're going to distribute that 3 to everything inside the parentheses and watch our signs. So then in this case, this would be 3x plus 12, that got rid of the parentheses, minus 2 is equal to 1. Next thing I'm going to do, I'm going to add 12 and minus 12 minus 2, excuse me. So this gives me 3x. And these are like terms. So this gives me, if I'm not mistaken, plus 10 is equal to 1. So if I did that correct. And then 3x. So let me go back here. So next thing we're going to do now is what? We got the 3 and the 10. Which one we're going to move first? We're going to move that 10 first. So the opposite of addition is subtraction, minus 10. What we do on one side, we do on the other side. That cancel. That gives me 3x is equal to a negative 9, if I'm not mistaken. Then we divide both sides by 3, because that's the opposite of multiplication. And therefore, x would be by itself, and x would equal to a negative 9 over 3, which is the same thing as a negative 3. And that would be our answer for the problem. Okay. Let's look at one more. This is a nice one. And see what happened, kind of answer we get. So we got x squared divided by 2 plus 17 equal to a -1. So how do we get the x by itself? Well, in this case, again, we got to get rid of that 2 and that 17 on that side of the equal sign. And the one we're going to do first is going to be the 17. So subtract both sides by 17. That cancel. This gives me x squared divided by 2 is equal to, in the case when I add this, I believe is a -18. Now we need to get rid of the 2. Now how are we going to get rid of the 2? That's a division. That is x squared divided by 2. So we multiply both sides by 2. This a cancel because we do a one side to another side. So we have x squared is equal to a negative, in this case, a -36. And then to get x by itself, we take the square root on both sides. We learned that earlier, plus or minus. Don't forget it's plus or minus. This is good because we saw this in some of our other lessons. We have the square root plus or minus the square root of a negative numbers here. So let's finish up our problem. So we got x is equal to plus or minus the square root of a -36. Now, if we recall, in the real number system, we cannot have a negative number in the square root. If that was a positive 36, then our answer would be plus or minus 6. But since it's a -36, we have an answer of it does not exist. And so you could write that down. It does not exist because we cannot have a negative number inside the square root. So it doesn't exist. If that was a positive 36, then the answer would be the square root of 36 would be plus or minus 6. But in this case, it doesn't exist because of the negative number inside of the square root. There are many more problems we can just write and solve, but using what you saw in this video and also from the previous video as far as solving simpler equations, you can combine and make your own problems and solve it, and you have the foundation. Again, look again over this video and look at some of our supplementary resources that we have on our Mathlink website. And again, let Mathlink bring it together.